So we want to figure out what this vector function look like in 3D space. And we want to match the picture with the function given. So first one is sine of t, cosine of t, and cosine of 4t. Projection of that on xy plane will give me what? It gives me sine of t and cosine of t. Sine of t and cosine of t. And that is a circle. That being a circle says that I can make sure that the first one is not the line, because the projection of the first one is not on the xy plane, is not a plane, is not a circle. All the other three are that way though. Now, the next part is to find a projection over, let's say, projection over x z plane, and that is x and z, and sine of t and cosine of 4t. Okay, so in this case, we quickly figure out that it actually, as x goes from 0 to 1, cosine z is going to go from 1 to -1 back to 1, and so from as x goes to 0, 1. So how does x go to 0, 1? X between 0 and 1. X has, then t has to go between 0 and pi half, just one round of going up. And so t goes from 0 to pi half. Cosine of 4t is going to go from 1 back to 1. So one complete basically change. That's what happens to it. And so it goes from this is 1, and we go up, down, up. Oh, sorry. At 0, it's 1. At 0, it's 1. So it's going to go up, down, up. And so x also goes to the negative side, so we will have that also. And so far, the only one that looks like that is going to be this one. You can try the YZ plane and you get the same result as this. Now, let's see, this was 2. Now let's try the second one. Cosine of t, sine of t, and t. Okay. Again, the xy plane projection is very much like that one. Cosine of t and sine of t this time. Cosine of t and sine of t, a circle. So it's in a circle, and then what you need to do is to do maybe xz plane or yz plane. Those are the ones that are kind of similar. So xz plane will be cosine of t and t. So basically an upside down cosine, or you can put the z in here and go x up there. And so And that's how it looks like. It starts from 1, goes like that. And so let's say t is bigger than equal to 0. It just looks like this. So which one of those is that? That's number 3. That's 3. Now, what else? Let's try this one. What is going to happen in that case? In this case, if I start the projection on the xy plane, let's see, xy plane, what do I have? I have 3, 2 e to the power t plus, I'm sorry, and 1 plus 4 e to the power t. What I need to do is to eliminate t, right, to figure out what it looks like. And so I solve for e to the power t in both of them. This is x. So it's 3 minus, x minus 3 divided by 2. And then on the second one, this is y. So e to the t is going to be y minus 1 divided by 4. And set them equal to each other. You get x minus 3 divided by 2 is equal to y minus 1 divided by 4. And simplify, clean it up, you get y is equal to 2 times x minus 3 plus 1. And this is an equation of a line. It's 2x minus 6. It's 2x minus 5. And so basically, it looks like this. Minus 5 goes up. If you do the same thing for xz plane, yz plane, again, e to the power t simplifies and you get line every time. And that looks like this equation. Now, what about this one? Let's try this last one. For the last one, which is cosine of t, sine of t, e to the power t, projection on xy plane is again cosine of t, sine of t, which is a circle. We do know that the last one is going to be number 4 because that's what is left, basically. We sort of suspect. It's just confirming that. And so that one does have xy projection that is circle. Now, let's do one more, xz plane. And xz plane gives me cosine of t and e to the power t. In that case, cosine of t is x, this is z. And so to eliminate t, t is equal to natural log of z, and x is equal to cosine of natural log of z. So in, let's say, z and x plane, and let's try just for z positive because that's the picture over there. And so for z positives, what do I get? Basically, in the very beginning, and as z moves between 0 and 1, I'm sorry, not quite 0 because you can't plug in 0 in the natural log. It starts from very negative values of natural log of z, and basically the negative values of natural log of z, so you will have a lot of going crazy right here, and then basically the growth of z slows down after that, it goes little bigger and bigger, and that's what this projection of xz look like over here as well.